conic section is going to be parabolas. Okay, now parabolas are a little bit different because so far everything we've done has had a square on both the x and the y, which is why we end up with two pieces. By two pieces, I mean if I had a circle, technically it's two half circles put together. Okay, same thing with the ellipse, they're just not perfect circles, so they kind of do that number. And then the hyperbola, of course, is two of those pieces facing away from each other, hence the minus sign in hyperbolas. Okay, these two have plus signs because you're adding the two pieces together, so one piece and one piece. Now when you're talking about this, I only have one piece that's squared, which means I'm only going to have one piece. So that's basically what's happening with the parabolas. Now you've seen parabolas in the form y equals x squared, but these are going to look just a little bit different. They're in vertex form, first of all. Okay, everything we're doing in this unit is all about vertex form. And so it makes them look just a tiny bit different, but I think you should be alright. Most of these things are still the same thing. So when we look at this, if I have the x as my non-squared term, that makes it a horizontal axis, meaning that it will face left or right. So just going to kind of draw one here. Okay, the parabola, of course, is typically a U shape, but now it's going to look kind of like a C because I'm going to be facing right. Okay, if I flipped it, that would be our normal parabola that you're used to seeing. Alright, so facing the right, and again, that's because we have the x is not squared, the y is squared. We're not used to seeing y squared equals x. We usually say x squared equals y. So that's why this thing is flipped over on its side. Now it says it right here, if p, okay, and p, I'm going to talk about what p is, but if it's greater than 0, so if it's positive, so if the number in front of your x here is positive, then it opens right, and if it's negative, it opens left. Okay, so what is P? Well, P is the distance from our vertex to our focal point. This is P. Okay, our focal point here is P away from our vertex. Now, something I want to mention about the vertex, because when we looked at the hyperbola, this was the vertices. Now, the difference here is we don't have a center of this thing. Okay, there's no center when there's only one piece. Before we had a center that was here and that was our HK. These were our vertices. Now our vertex is our HK. Okay, so this point is our HK. So our vertex with the parabola acts like our center. Okay, so we're going to go over P units. Now notice the focal point is inside of my parabola. If my parabola were facing left, my focal point would be inside, so it would be on this side. That is important, and if you want to write that down, the focal point should be inside our parabolas. Okay, the focal point is inside of that parabola. That's super important. Okay, so this direction is the focal point. Now, these things are all about symmetry, so we have to go the other direction as well. And when you go the other direction, P units, you will find what we call the directrix. Okay, the directrix. That's this line. It is a dotted line. Okay. It is a dotted line, so this is the directrix. Spell that out for you. Okay, now our directrix, it actually does have a special property, and the property goes to the distance from here to a point to the focal point. Okay, and there's a special property that goes along with all that, but we're not going to look at a whole lot of that. Okay, we're actually just going to graph the directrix, so I won't go into explaining what the directrix actually is. But do know that it does actually have a special property, just like when we talked about the ellipse, the focal point. If you went from focal point off the edge to the other focal point, it was an exact same distance no matter where you put that, that point on the ellipse, and this has that similar kind of property. So please keep that in mind. It does actually have a purpose. We don't just like randomly put things, but in this class we aren't going to go into the purpose of it. You would look at that if you moved on in math. So right now we're just going to leave it at that. So that is my directrix. Okay, now we also have a focal width. Okay, and the focal width is the length, okay, of the entire width of this parabola through the focal point. That's why it's called a focal width. Okay, so if I were to do this right here, this distance right here is the focal width which we usually just, you'll see us abbreviate as FW because it's focal width. And the focal width is for P. So 4 times the P value is your focal width, which happens to be the number that's going to sit out front. Okay? So the focal width is 4P. I do want to mention that it is a distance, so it's always going to be positive. Okay? We're not going to look at negative focal widths because it doesn't make sense to have a negative size. Okay? So the other thing that we also have is the axis of symmetry. Now the axis of symmetry goes through the vertex and the focal point. Okay, and these parabolas are perfectly symmetric on either side. So if I were to fold it over on its axis of symmetry, I should get an exact replica on the other side. Now, mine's probably not exact because I'm just kind of hand drawing these things, but that's what we're looking for. Okay, it should be a symmetric, so it should be exactly the same side, same on both sides. Alright, so that is the, oh, I didn't write that down. So that's the axis of symmetry. Symmetry, helps if I spell it correctly, which I usually write AOS for mine. Okay, it's going to be the AOS is what you're going to see it as, and that's this thing right here. It's your axis of symmetry. Okay, now for the horizontal axis, the focus, okay, we're going to go from that center, that HK, and we're going to add P to get to the focal point. Okay, if it was negative, we would, or if it was negative P, then you'd go backwards. And for the directrix here, it's H minus P, so you go backwards to get to that directrix. Notice that it is an equation. X equals H minus P gets me right here. Okay, when you go to the vertical one, same parts. Okay, so we have a vertex which sits there. I have a focus that sits here. Okay, I have an axis of symmetry that bisects this thing right in half. And I have a symmetry, goodness. Okay, I have a directrix that's going to be P units down. Okay, so this right here is P, this right here. Oh, I didn't really make them very symmetric, but they should both be the same size. Okay, P units up to the focus, P units down to the directrix. And I have a focal width that goes from here to through the focus to the ends here. These actually do have names. They're called EOLR, or the ends of the latus rectum, because that's actually the name of this little axis here. But we don't have to go that in depth. We're just going to call it the focal width. Okay, we're just going to call it the focal width, and we're not even going to make you write down those coordinates, so that works out nice. Okay, so that's your focal width. I've got my directrix, I've got my vertex, I've got my P value, and my foci, or focus, foci, whole plural thing, okay, foci. Alright, so that's what we're looking at. Here with our vertical one, if P is a positive value, then it would open up. If P was negative, I would open down, which means my focus would be down, or here it would be up. Okay, we would go down for the focus for this one. My focal point is going to be K plus P. Okay, K plus P, and my directrix is Y is equal to K minus P. Okay, focal width is always 4P again, so it's still that number out front. Now they tell us some extra information on your notes here. The axis of symmetry is perpendicular to the directrix, which hopefully you can see. Okay, these two things are perfectly perpendicular. Okay, meaning that if this one is, if the directrix here is X equals H minus P, then the axis of symmetry has to be Y equals, because they're perfectly perpendicular. So it's going to be Y equals, and that Y is going to equal K, whatever K is. Okay, and here same thing, axis of symmetry. So if this one is Y equals for the directrix, that makes it X equals H for the axis of symmetry. Okay, Okay, so if you want to include those, you can do that, because we're going to include the axis of symmetry on our notes here just for good measure. All right. So let's go ahead and take a look at this. The rest of that stuff we already talked about. The vertex is the midpoint between the focus and the directrix. You can see that. Okay, vertex is exactly in the middle between the foci and the directrix. The vertex to the focus and directrix is P. Okay, we already talked about that. So, first of all, they don't ask you to identify direction, but I would highly suggest that you do identify your directions, because it's going to help you when you go to fill in the rest of this thing. Okay, so starting with x is not squared, so that makes this thing horizontal. Okay, and the 8 is positive, so that makes this thing open to the right. Okay, if it was negative, it would open to the left, but it's positive 8, so it's going to open right, and it is horizontal. Okay, my p value, well, this, according to our formula, okay, if you look at our formula right here, the number in front of the x is 4p. So that makes this number 4p. So if 4p is equal to 8, well then p must be 2. So p is going to be 2. Now the vertex you find just like you did the center on every other conic. So you look for what number is added to x. Well, there's nothing, so that makes that vertex point 0. And what's added to y? Okay, there's nothing. It's just y squared, so that vertex point is 0. Okay, so 0, 0 for x and y. And I'll show you when it moves in here in just a second when we look at this one. All right, so then the focus. Well, to get to the focus, I'm going to have to start graphing. Once I have these two things, I can graph my entire thing. Okay, so starting with 0, 0, there's my focus, or my vertex, sorry. That's my vertex, which is my new center, if you will. Okay, and it's p equals 2. So to find my focus, I have to move 2 units. Well, what 2 units do I move? Well, this thing is opening to the right, so I know it's going to move in this direction. So my focus has to be inside, so I have to go right 2 units to get to my focus. Okay, right 2 units to get to my focus, because the focus should be inside my parabola, inside the cup, inside the satellite dish, whatever you want to call it. Okay, write down that point. So you get 2, 0. Okay, is my focus. Now to get the directrix, you just go p units the other way. So this is p. Okay, and we're going to go p units the other way. That's my directrix, but it's not just a point. Okay, the directrix is not a point, it is a line, so it is going to be a line that goes vertically. Now I know it goes vertically because the directrix will never, ever, ever touch my parabola. So I have a parabola going this direction, which means that my directrix has to be a vertical line here. Because if I did a horizontal line, well, first of all, that's not just an x equals -2. That's a whole bunch of other stuff. But it also would hit my focal point. It would hit my vertex, all kinds of stuff. So it's got to go vertically. So writing the equation. Okay, well, 2 ways you can look at this. The way that I've always remembered is the non-squared piece. So it's x. It's horizontal. So this is going to be x equals. And what does x equal at that point? -2. Okay, x equals -2. Or you just remember that if x is negative, x right here is -2. Okay, if it was y -2, that'd be down here. Y -2, well, I can't go that way. That'd be y equals everything. Y equals -2 goes that way. So x equals -2 would be right there. So x equals -2. Focal width is just this number. Whatever that number is, that's your focal width. Okay, so the focal width is just 8. Last thing, I want to add the axis of symmetry. So the axis of symmetry is going to go through the vertex and the focus. Okay, so to go through them, straight line, perpendicular to my directrix. Notice these things are a perfect 90 degree. So that point right there is going to be y equals, okay, well, what does y equal there? 0. Hasn't gone up, hasn't gone down. It's right on that axis. Now, good ways to check. Again, here the non-squared term should be the same as my directrix, so it's x and x. It's horizontal, horizontal. Remember, x is horizontal. Okay, and then we also have that these two should always be opposite. So if this is x, this must be y. So those are just good ways to check yourself to make sure you're doing these things correctly. Now the last thing we need to put on there is that focal width. Okay, so when you talk about the focal width, our total focal width is 8. So if I have a total width, I need to go from end to end is 8, and my focal point is in the middle. Well, that means I would have to go up 4 units and down 4 units. That would give me a total of 8, okay? From here to here would be 8 units. And you don't have to do all these where I labeled P and 8 and all that stuff. Okay, I'm just trying to show you for your notes. So from here to here is 8. So you will always take your focal width, split it in half so you know how far to go from the focus. Okay, the big thing is that in the end, your total width should be this number. So from here to here is 4, and then 4 more makes 8. Now you just draw your actual parabola by going from vertex through those points, okay, from the vertex through those focal width points, the ones at the end of your focal width, graph those, and that would be your parabola. Okay, so that's your parabola. Now that one's from 0, 0, so we're going to take a look at another one that's not from 0, 0. Okay, so if you take a look here, I've got x plus 4 squared is equal to negative 4y minus 2. So the very first thing I want to do is I want to identify what direction this thing is going. Okay, so y is not the squared term. Okay, y is not squared. So to me that says this thing is vertical. And then this number out here, okay, since this number is negative, that means it's going to be upside down. So it's vertical, but instead of being facing up, it's going to face down. Okay, bowl facing down, which means focus is going to be inside here. Okay, remember your focus is always inside your parabola, so focus is going to be down. Alright, so now find my p value. This is 4p, always. So 4p equals negative 4. Divide by 4. So p equals negative 1. Okay, p equals negative 1. So I also have to find my vertex. Again, we find this like we did center. Okay, so look at what's added to x. So x plus 4 becomes minus 4. Y minus 2 becomes plus 2. Always change the signs. X goes with x, y goes with y. Okay, so then we also have the focus point, but I can't do that until I start graphing, so let's go ahead and put this stuff on. So I've got x is negative 4, y is positive 2. Graph that point, so when x is negative 4, y is positive 2. Okay, and now p is equal to negative 1. Well, it's down, and my focus needs to be inside. So to get to my focus, we go minus 1. There's my focal point at minus 1. So write down that coordinate. So when x is negative 4, y is positive 1. Okay, I also need to find my directrix. So if I go down to get my focus, I must go up to get to my directrix. Okay, so go up 1 unit and draw your directrix. This time my directrix is horizontal. Okay, because if I went vertical at that point, I'd just go through my focal points, and I can't have that. So here I have to write the equation of this line. Y is not squared, so it's y equals, what does y equal? 3. Okay, y literally equals 3. Y equals 3 across that entire line. Okay, so y equals 3 is my directrix. Focal width is this number. Now we're going to leave the negative off, because when you talk about width, you can't have negative width. That doesn't make any sense. Okay, so when we talk about width, we're going to leave off the negative. So the width is just 4. So what that means is if my width is 4 from my focal point, make sure you go from your focal point. If you go from your vertex, you're going to get a flat parabola. They will not be flat. They might be kind of flat, but they will never be flat. Okay, so they should not line up. So from the focal point, however, you go left 2 and right 2. Make sure you divide that into 2 pieces. Left 2 and right 2. that gives me a total width of 4. From here to here is 4. Okay, that's my focal width. I also want to do axis of symmetry. So this was y equals, so I know this has to be x equals. And what does x equal? Well, x equals -4. You don't really have to draw the axis of symmetry. I'm just really doing it for your sake of your notes so you can kind of see what I'm talking about. So x is equal to -4 would be that axis of symmetry. Now all you have to do is draw your parabola, which is going to be a little bit fatter here. Okay, you just kind of do the best you can. You try to stay somewhat, see I got a little out of control and I'm going to fix mine. You try to stay somewhat consistent as far as the axis of symmetry goes. Okay, because it should be the same on both sides of my axis of symmetry, which is totally crooked because I don't have lines on this. But on your test, we'll make sure you actually have lines so you can make these things nice and pretty. But there would be my parabola. It's facing down just like I thought it should because this is negative. It's down because this is y. My vertex is at -4, +2. My p-value was -1, so we went down 1 for my focus, and we went up 1 for my directrix, and we wrote all that stuff out. So we're going to do one more together, and then I would suggest that you hit the pause button, or if you think you're ready now, hit pause, come back, see if you can do these last two. Okay, I'm going to keep on working through them. So here I've got, it is horizontal, and this is positive, so it's going to open right, which puts my focus inside the cup there. Okay, focus inside, focus inside, focus inside. I feel like a one of those prophecy people, those Chinese prophecy, focus. Okay, I'm going to start telling you all kinds of crazy stuff. Just kidding. Alright, so P, 4P equals 2. Right? This is 2, and it's always 4P. We get the 4P from the formula. Look back at the formula. This number equals 4P. So divide by 4, which means P is 1/2. Okay? It's going to be a teeny tiny little thing. Everything's going to be smushed together. That's fine. So the vertex, when X, now be very careful here. They're not in the same order now. Okay? When I do this, I need an X and a Y value, or an HK. This is my X, or my H, -7, and this is my Y, so +1. Okay? -7, +1, -7, +1. Be careful with those. Make sure you put them in the right order. So to do my focus, I need to go ahead and graph. So -7, +1, make my dot. Okay, to get to the focus, now this is opening to the right, so to get to the focus, I go to the right 1/2. Okay, so this stuff is really right on top of each other. So that point right there is -6.5. 1, that's point, not comma. That was horrible. -6.5, okay, and 1. And then to get my directrix, I go the other direction. So I'm going to go to the left 1/2. And we're going to make a line, which I'm going to do my best at making kind of sort of straight. Okay, so there is my directrix, and that thing is not quite to the -8, it's actually at x equals, because that's what x equals, is -7.5. Not y, because if I did y equals, well, y equals -7.5 would be down here going that way. So x equals -7.5. Focal width is still just this number, so it's 2. Okay, so that means from my focus, I'm going to go up 1 and down 1. So down 1 is there, up 1 is there. Okay, and then you just go through those focal points, focal width points. Okay, it's a little bit skinnier graph, not a whole lot more. Okay, but that's my parabola heading off to the right hand side. Okay, axis of symmetry Well, it's going to go right through the vertex and the focal point, which is, should be, it's kind of hard to tell on mine, but it should be y equals, right? Because what does y equal? Y should equal 1. And I know it's 1 because the vertex there is at 1. So y equals 1. I don't know why I threw a parenthesis at the end of that. So y just equals 1 is that. So if you haven't already, hit the pause button, try this one. Okay, come back, see what you got, see if you got the same answer. I'm going to go a little bit faster on this one. This thing is vertical because it's y not squared. It is going to be down because it's negative. Okay, this thing right here is negative, so it's down. That puts my focal below it. Okay, my p-value, negative 12, is equal to 4p, so divide by 4. P is equal to negative 3. So negative 3 is there. My vertex, nothing added to x, so it's 0. Positive 4 on y, so it becomes negative 4. Okay, so 0, negative 4 is my starting point, which is down here. Okay, and then I'm going to go down 3 units because it's minus 3. So it's facing down, so we're going to go down 3, and that's my focus. So when x is 0, y is negative 7. I'm going to go up 3 to get to my directrix, and I know I've got to go sideways to make that happen. Okay, so that directrix happens at y equals, because y is not squared, and it's going through the y-axis, so y equals negative 1. And then focal width is just this number, drop the minus sign, so it's just 12. So if I have a focal width of 12, that means from my focus, I'm going to go right 6 units, and I'm going to go left 6 units. Okay, 6 because I want a total width of 12. So 6 plus 6 gives me a total width of 12. Axis of symmetry, I hope you did. Well, it goes right here across this the y-axis. Okay, so it's vertical, so that's going to be x equals 0. Okay, x equals 0 because I haven't moved right, I haven't moved left. Okay, it's just sitting right dead center. Alright, so now you just need to draw that parabola through those points. This thing is going to be a lot wider. Apparently better at going one direction than I am the other on these graphs, but that's okay. Alright, so there is my parabola. Now, the last 4 that are on here, okay, should be a little bit quicker, although we are going to add that I want to put an equation on these things. Okay, you got to be able to write equations. You got to be able to look at the information that you have and write your own equation. So start by graphing what they give you. They give me the vertex is at 0, 0, and the focus is at 0, 3. So when x is 0, y is 3. So if this is my focus, and this is my vertex, well, that makes this distance p. So p equals 3. Let me move it away from where I just said I was going to write my equation. P equals 3. Well, that also means that if I went up 3 to get to the focus, I must go down 3 to get my directrix. Okay, it's always just going to go in the other direction because it's going to be up positive p to get focus and negative p to get the directrix. So if I already went up, and this is what they told me, they gave me those 2 points, then I know I have to go down 3 to get the other one. Okay, so the directrix, go ahead and write that down. That's going to be y equals negative 3. Now I want you to be able to do these, so let's write an equation. Well, for starters, it's vertical. And we kind of have to because we got to be, well, I guess I could just multiply by 4, but we're going to keep on going. So it's a vertical graph, and I know that because my vertex and my focus lined up vertically. Okay, if it lined up horizontally, it'd be a horizontal graph. But here they lined up vertically. Okay, so since they lined up vertically, we are going to put the x first. Okay, because the y is going to be the one not squared. So I've got x. Now, I would look minus h. Well, what's h? It's just 0, so that's going to go away. So I just get x squared is equal to, and keep in mind we're using this formula right now, x minus h squared is equal to 4p y minus k. Okay, that's what I'm using at this very second. So x is 0, so I just get x squared. 4p is going to be 12, okay, because 4 times 3 is going to give me 12. That's 4p. Okay, so then I've got y minus k, so that's y minus 0, so that's really just y, right? We don't have to put the minus 0 on there, so just y. So x squared is equal to 12y. Now the last thing I want to do to finish graphing this is I now have my focal width, which is 12, so I'm going to go right 6, plot a point from my focus, left 6 from my focus, plot a point, and now I can finish drawing my graph. Because otherwise I can't finish drawing my parabola because I won't know how wide it is. And you have to plot those points to know how wide it is. If you don't plot your two focal width points, you will lose points. So please make sure you're plotting those 2 points. Okay, so the same thing on the second one. So now this time they're going to give me some different information. Now I've got to find focus. So they give me that 4, 0 is my vertex. They also give me that y equals 6 is my directrix. So go to where y is 6 and I draw I know it's horizontal because if I do vertical then I would just go straight through that whole thing and y would be all numbers, and that's not what we want. We want y equals 6 and 6 alone. Okay? Y equals 6 you can actually graph in your calculator. So if you forget and you're like, I can't remember if it's supposed to be horizontal or vertical, plug it in. The only one you can plug in is y equals 6 and you'll see a horizontal line. Okay, so we've got a directrix there. So if this is the distance from vertex to directrix, that is also p. Okay, so p is the distance from the vertex to the directrix as well as from the vertex to the focus. So that means if I went up 6 to get to the directrix, I will go down 6 to get to my focus. Okay, so I went down 6, so that means when x is 4, y is negative 6. Now, you have to figure out what is p. Okay, so if p, I went down 6 units, that means that p is negative 6. Okay, it's negative because to get to my focus, I went down. Okay, to get to my focus, I went down. And hopefully you can see that this thing is going to be shaped this way. Okay, because here's my vertex, here's my focus, so if it's inside my cup, this thing has to kind of fall around it this direction. Okay, I'm not going to draw my lines yet because I got to figure out how wide it's going. Okay, but it is going to fall this direction. It's going to open downward because there's vertex and I have focus, so there it is. I can't go this way. Okay, because if I go this way, then that thing's not going to be in my cup. And if it is, then I have to start like making up things, and that doesn't work. Okay, vertex right in between focus and directrix. So now I just want to write an equation for this thing so I can figure the rest of it out. So I've got, it is a vertical graph again. So vertical means I'm going to start with x, so I'm going to use that same formula. So here we go, we get x. Now here it's not just x, I've got 4 units as it moves, so we're going to change it to minus 4, okay, because this is my h and this is my k. Again, I'm using that same formula, okay, it's written right there, x minus h, well h is 4, okay, is equal to 4p, okay, 4 times p, well that makes negative 24, y minus k, well k is just 0, minus 0. Okay, so really that minus 0 can just go away. So I'm just going to erase it since I'm erasing anyway. So negative 24y. Forgot my square. That's horrible. Okay, that first piece must be squared. X minus 4 squared equals negative 24y. And I got rid of the rest because it was just minus 0 and the 0 is going to fall off. So that makes my focal width 24, which means half of that is 12. So this thing is going to go off my graph a bit. Okay, so we're going to go 12 left, which will take me to the negative 8 mark. Okay, because negative 8, 4, that's negative 12. And then we're going to go 12 the other direction, which we don't even have on the graph, so I'm just going to kind of guesstimate it out there. And then we are going to connect our vertex to our focal width points, which are way out there. Okay, so there would be my focal width points. That's close enough. It's kind of an ugly looking graph, but that's alright. Again, it's not going to have to be perfect. It does have to look like you tried, though. Alright, one more for me to do by myself, and then, well, not really by myself. Hopefully you're doing this with me. Hopefully you're not just sitting here, although that's fine too. At least you're watching the video. Kudos to you if you've actually sat and watched the video. Makes it all worthwhile. Alright, so they give me the focus. The x is 0, y is 1. Here's my focus. My directrix, x is equal to 2, so x equals 2, which is a vertical line at x equals 2. Now this time they don't give me my vertex. So if this is focus and this is directrix, well, the vertex is right in the middle. Okay, the vertex has to be in the middle, so that makes my vertex at 1, 1. Well, that makes my p-value. Okay, well, I moved 1 unit left to get to my focus. So if I go 1 unit left, that makes -1 my p-value. Okay, so plug it in. Now I'm going to use, this is a horizontal graph this time, because to go through the vertex and be around my focus, it's going to go to the left is how we're opening. Okay, hopefully you can see that. Vertex, we're moving away from our directrix, so it's got to go this direction. Okay, so if I were to write an equation, that means now my y will come first.
Denise Toro, if you're on campus, you're needing a White House 1. Denise Toro, if you're on campus, please report to White House 1.
Okay, so that's going to be y, and then it's y minus k. My k value is 1, so y minus 1 squared is equal to 4p. Let me write down the equation for you. Y minus k squared equals 4p x minus h. I'm really just filling in the spots. That's all I'm doing. So 4p, p is -1, so that makes -4 x minus h, which is 1. Okay, and there's my equation for this thing. So that makes my focal width 4. So that means from my focal point I would go up 2, and I would go down 2, and that would give me my focal width, and then we just connect those points so we can finish graphing. Alright, hit the pause button, try it, come back, see if you can get the right answer. Okay, make sure you do all the parts, make sure you write the equation is really what I want to see you do. Okay, writing the equation is a little bit harder, and that's what I want to see if you can do. So, try that. Come back. If you're coming back, welcome back. So, vertex, when x is 2, y is 3, there's my vertex. My focus, so when x is 4, y is 3, that means there is a distance of 2. I went 2 units right, so that means I'm going opening to the right, because I went 2 units right for my focus. That means I'm going to go 2 units left for my directrix, which puts me right here at x equals 0. X equals 0, because that's what x equals right there. So x is equal to 0. So now I need to identify my p-value. Well, p, I went 2 units, so that's p equals 2. And we went to the right this time, so it is positive. So let's write an equation. Since it's horizontal, that means that y will come first. So we're going to go y. Okay, and then go to your vertex, because this is your hk value. So y minus 3. Let's move it over just a touch so you can see I'm plugging into this formula right now. Y minus 3 squared is equal to 4p. So that makes 8, because 4 times 2 is 8. And then x minus h, which is 2. Okay, plug that stuff in. That's it. Y minus 3 squared equals 8 times x minus 2. That makes my focal width of 8. So we're going to go up 4 and down 4. And you have your very last little parabola for our notes. I hope this helps. Okay, if not, please come to tutoring. We can do more. I can explain more, whatever you need, whatever we can do. We are getting close to that finish line, close to that graduation date, so if you need help, please come in. Mondays after school, Wednesday after school, or Friday morning. Good luck with the homework.